So number one, we have to write down a formula to represent the number of rabbits P in the population after X years. So here is the formula. How do we come up with this? Well, we see that we start with 60 rabbits. That's the population when we begin, so 0 years. After 1 year, we have to, as we can see here, 30%, we increase 30% in 1 year. So 30% of 60 is 18. So 60 and then 18 more, 78. And then after 2 years, it's going to be 30% increase. So 30% of 78. 30% of 78, 23.4. So we're gonna have 101.4 rabbits after 2 years, etc. So we can just keep going like this, add 30%, and we'll have the population after 3 years, etc. So we have to understand when it's an increase, we add 30%. That's why it's 1.30. So if we just try some different values here for x, for example, x is equal to 0, insert this into the formula, 1.30 to the power of 0. It doesn't matter the number here, anything to the power of 0, this will be 1. Okay, so 60, which is okay. So when x is 0, population is 60. If we have x is 1, it's going to be 1.30 to the power 1, which is 1.30. So just 60 times 1.30, which is 60, and we add 30%. So we will have 78 rabbits after 1 year. So you can just very easily see that this formula represents the numbers here in the table. Number 2. Well, I like to insert the formula in the calculator and just define it, then it's easier to work with it in the calculator. So how about we define it? P of x, define, control, and this symbol. 60 times 1.30 to the power of x, and then it says done, which means that it understands what we've written. It's okay, and now we define the function p of x. So they want us to find out the population after 5 years. So we're just going to write p of 5 because x is 5. 222.7, so we're going to say 223 rabbits. Number 3, when will there be a population of 827 rabbits to the nearest year? So let's use the solve function. We go to menu, algebra, oops. Let's see. That's it, this one. Let's see if we can plot this one. 60 times 1.30 to the power of x. And we have to zoom out to be able to see it a little bit better. Okay. Let's do zoom box and start from 60. There we go. A little bit better. So we can see that here at 60 it increases like this. Now I would like to use the let's see, I can't recognize. Let's see if this is the correct function. So p of x is equal to, what was the number? 827. 827 comma variable is x. So when the x is basically 10, so after 10 years we'll have a population of 827. So question number 3 will be 10 years. When there are 827 rabbits, the population is infected with a virus and the population decreases rapidly at the rate of 50%. So decreases, this means that this factor is going to be 0.50. Okay, if it was an increase it would be 1.50. It will increase. Now it's decreasing. So we can kind of use this table. So let's start the timeline again at 0. So this has happened after 10 years. We have 827. Then we kind of reset everything and say, okay, x is 0 and the population is 827. How does this change the population now? So 827 and times this factor, which is 0.50 to the power of x. So 827 times 0.50, 413.5. Can just keep going like this. After 2 years is 50% of this, so a little bit more than 200, etc. And this is the formula that will represent how this develops. After how long to the nearest month will the population be 60 again? So let's use the same function. We have to define a function. Let's choose p of x. We define it 827 times 0.50 to the power of x. Done. Then algebra, when is p of x equal to 60, right? Comma x. Let's make sure. Yes, 60. Okay. So let's see. After about 4 years. Okay, so let's try this. Just times 0.5 times 0.5, 2 years, right? Oops. Times 0.5. times 0.5. So after 4 years, it's a little bit less than 60. So exactly 60 is going to be 3.8 years. So it seems to be reasonable what we come up with here. So to the nearest month, 3.78. To the nearest month. So how many months? Well, 3.78 485 times 12, because this is in years and 12 months per year. So 45 months. Okay, this formula is for number 4. Number 5 is 45 months.